Mr. Pelton. This is Algebra 2, Chapter 5, Section 4. This is Part 5 of the video. So again, refer back to the list given in this section on the transformations and what each piece does, and the overall transformation sheet given at the beginning of the course. So the things we have here is a 4, a negative, a -2, and a 3. So what do each of these do? Well, adding and subtracting, those are translations. The inside is horizontal, the outside is vertical. So this is a translation up 3 units. And the -2 is a translation right 2 units, because inside is counterintuitive, outside is straightforward. So the 4 is on the outside. Excuse me. That is on the outside, so it affects y. Multiplying and dividing is stretching and shrinking. So this is a vertical stretch. And the negative is in the inside, so that it switches your x value. If you switch your x value, you did a reflection on the y axis because you changed your x value. Your x's went from positive to negative. So this is a vertical stretch by a factor of 4. Okay. The next problem, we have a -5, a 2, and a negative. That is it. We only have 3 things. And this negative is on the outside versus this negative was on the inside. And it always affects the multiple. In this case, the multiple is only a 1, but that's fine. All right, so the -5 is an adding and subtracting. So there's a translation down 5 units. The 2 is in the inside, it's a multiplying. So it's a inside, so it's horizontal, it's x. It's multiplying, so it's a scaling. In this case, it's actually a shrink because multiplying by 2 is counterintuitive on the inside. Everything's counterintuitive on the inside. And the negative on the outside affects y. Everything on the outside is y, inside's x. If you change your y value, you reflect it in the x-axis because we changed our y since it's on the outside. Oh, and the 2 is a horizontal shrink by a factor of 2. Okay, pause the video, try the student problem for yourself. Okay, so the student problem with log base 5, what are the things that are being done to it? There's a 4, there's a -6, there's a 2/3, and then there's a negative on the outside there for the reflection. Adding and subtracting are translations. So this is a translation left 4 units. And this is a translation down 6 units. Keep in mind the inside is counterintuitive. Inside affects x, outside affects y. 2/3 is on the outside. It's a multiplying. Multiplying and dividing is scaling. So this is a vertical shrink by a factor of 2/3. Okay. And lastly, the negative on the outside affects your y. So it's a, almost word vertical, a reflection. Marker's messing up. Reflection in the, so it's on the outside affects y. So you changed your y value. So it's reflecting in the x-axis as we changed our y value. Okay, so next we have a log base 1/3. So you notice the base is kind of irrelevant to all these logs because the transformations affect the log, whereas what the log is the same way. So we have an 8, a -7, a 3/5, and a negative on the inside. and that's always a negative in the multiplier, the coefficient that does the reflecting, if you look back at the rule. So 8 on the outside is a translation or shift up 8 units. And -7 is a translation right 7 units, because inside's counterintuitive. Inside's x, outside's y. 3/5 is on the inside, so it affects x, so it's a horizontal. So multiplying is a stretch or a shrink. In this case, it is a stretch by a factor of 5/3. It's always counterintuitive on the inside. And the negative's on the inside, so it changes x. So it's a reflection on the y-axis since I changed my x value. Okay, let's try the next problem. So next problem, the parent function is a log base 1/2 with a 3 on. You have to do 3 different things. Stretch vertically, translate 2 units up, and reflect in the y-axis. So given the order of transformations, which is horizontal translation first, stretching and scaling, which is stretching and shrinking second, reflections happen third, and vertical translations happen fourth. Based on what we have here, the vertical stretch happens first because we have no translations left or right or horizontal. The reflections happen second, and the translations up and down happen third, which is normally fourth. So we have to do 2 times f of x, since it's vertical, it's on the outside for the stretch. So that's 2 times log base 1/2 of x plus 3, which is incorrect because it's 2 times the entire f of x. So you need parentheses or grouping symbols. So 2 times log of 1/2 of x plus 6. So the next one is reflect in the y-axis. If I reflect in the y-axis, that affects the x value being switched. So that's going to give me 2 times log base 1/2 of -x plus 6. Okay. And then lastly, we have a translation 2 units up that affects y, so that's on the outside. So that's f of x plus 2. So that's 2 times log base 1/2 of -x plus 6 and a plus 2 on the outside. For a final function, which you can call anything you want, just not f of x, it's a new function of 2 times log base 1/2 of -x plus 8. Pause the video, try the student problem for yourself. All right, so you have a common log, which is log base 10, if it's not specified. And we need to do these 3 things to it. Based on this, translating horizontally comes first in the order of transformations. Shrinking and stretching, which is scaling, comes second. And third is reflections. Fourth would be vertical translations. There weren't any, but there are none here. So transiting 5 units to the left, it's x, that's on the inside, so that's x plus 5, because it's counterintuitive inside. So plus 5 is actually left. So this is log replacing x with x plus 5. The second being shrink horizontally by a factor of 3. So that's horizontal, so it must be in the inside. So if I'm shrinking, I actually have to multiply by a factor of 3. So I get log of, my pen's not working. There we go, 3x plus 5. Remember, the inside's counterintuitive. So shrink would be the multiply, and stretch would be the divide. And the last is reflect in the x-axis. So that's going to be in the x outside, since I'm changing my y value to go over the x-axis for the third one. So that's negative log of 3x plus 5 for my new function of g of x, which is negative log 3x plus 5. And that is the end of part 5.